sorry, it's my fault. One again, we have to write subplot 2. Just a second, sorry. Okay. Show on. Two for saturation and subplot 1, 3, 3 for value in this color space, or we can say that's equal to intensity in the HSI color space. I can see here the hue matrix or hue image, intensity, and the value or intensity image here that we call it grayscale image. It means that is equal to the grayscale image. If we use RGB to gray, we can find this image again if we use RGB to gray count. And also you remember that we say that I said that in the hue we have the color that that are in the image. In the intensity we say that how much of this color are in the image, and the last one is the intensity or value in this image. You know, if I showed some example of the histogram equalization that we talked about it 3 weeks ago, you know, we can use let me to close all windows. Okay, figure. We can write imhist of the B excellent, we have to put A because the A is in the grayscale, and we can find the histogram of the grayscale. We can't find the histogram of the color. Or if we want to find this, we have to find the histogram of each image, R, G, and B image in the color image. And you can see the most values in this area of the histogram, because if I let me to show you the image of the A, show A. You know, we have a dark image. So the spot of dark here and here. It means that most of the values in the range of the 0 to 50, that we have the black. We know that the 0 is black color, and when we go to the 255, we have the white color. As you can see here, most of the values are in this part. Means that we have a dark image. We can use histogram equalization to enhance the illuminance of the image. In this one, we can use, for example, E equal to histogram equalization of A. Okay, then we can show P, and you can see that as the illumination of the image, we can see more details here, for example, in this part. But in the original image, if you see this, the all parts are dark. You can see any details, for example, in this part, or some details here. So, and also if show the histogram of the Okay. Let me do. Okay, it's the new histogram. Values, we know that we shift some values to the right side. It means that we have more value in this area rather than in this area that we have some dark gray. For the example of the histogram equalization, and also you remember we talked about some smoothing image, smoothing filters and sharpening filters. If you want to use this filter in the MATLAB, we can write, let me clear all, let's see, clean all, just let me do A, butterfly, okay, we have a color image. We want to use the filter, for example, the smoothing filter, like averaging filter. You know that for the averaging filter, for the smoothing of the image, we can use average filter. If you want to use these filters, we can use the F special comment. If you want to see that, you can write hell F. It makes some filters for us. You know that we can use average filter for smoothing. This Gaussian, Laplacian, Laplacian of the Gaussian, we call it log, motion, Prewitt and Sobel, for example, to find the age of this. It means that you can use this command to generate some filters to use for the smoothing or sharpening. For example, if we want to use this, but before, let me to change the color space of the image from the RGB to HSI or HSV, RGB to HSV. Okay. Now we have the image in the color, in the RGB color space and HSI color space. As remember, we said that for the applying the filter on the image in order to smoothing or sharpening, we can apply the filter on each component. It means we can apply it to the red, blue, and green separately, and after that we use it. Or we can consider the value as a vector, then apply the filter on the vector. If we want to apply the filter on the image, we can use, for example, PP equal to M filter. No, let me to first make the average filter first. H is our kernel, F ratio. Okay, for example, average, we need the average filter for smoothing. Average. Also, we have to assign some size. Just remember, we have the, for example, 3x3 filter, 5x5 filter, something like this. We can assign the size of the windows, for example, windows of the filter by 3x3. Okay, we make the average filter here. If I want to show the average filter, the value of the average filter is like this. As you remember, for the average filter, we had some kernel like this, 1/9. Okay, we had amounts like this. Then, if you divided each pixel by 9, we can find this value. It means that we have the average value that we can use it for smoothing. If I want to apply this to the image, we can use, for example, for the average image, or yeah, we can call it average image. We can use AMP filter. The image that we want to apply, the kernel on this. This is A, and the kernel that we have, that is equal to, that is H. Okay, we find the we apply the smoothing filter on this. If I want to show it to you, show A figure show average image. You can see here we have a little smoother image rather than the first one that is a little sharper. For example, in the white part, I want to show it. For example, here you can see that we have a sharper edge rather than this one. Also, you remember that I said that yesterday. I said that we can apply the filter on the HSI color, but some of you was in the class. What happened if we apply the filter on the hue component of the HSI instead of the instead of the intensity? Means that, for example, for B that we have the HSI color. What happens if we apply the filter on the hue component instead of intensity? The people that were in the yesterday class know that if we applied it on the image, we destroy the image, because you know that in the hue component we just have the colors that are in the original image. Means that, for example, if we use this in, for example, R in filter, okay, on the first component of the image in HSI, that is the hue, okay, and H. Okay, if we can write it B first component is equal to R. Okay, if we want to show you the image, we don't have any, but okay. To show the image B, you know that we destroyed the image, and you can see that sorry. Do you know this shape? Thank you. You need this?
No.
No. Okay. Then we have to know that when we want to apply the filter on the HSI color space image, we have to apply it on the intensity component or the value component in the HSV color space. And that is what some example with hyperactive you will use these comments FSpecial to in your homework to generate some filters, and also you can use InFilter to apply the filters to the image to generate some smooth or sharp image. And I think that's it for today. Do you have any question? If you don't have any questions, it's the end of this lecture. I will see you next week. Gracias.